Hi guys. Today you get to see me on video instead of Dr. Harrison, and I'm here to hopefully explain to you how we would have done the Woolybooger Lab, and then how are you going to use the data that we are going to give you to make the correct calculations so you can create some graphs for your last lab assignment. So, just like everything, it's a bummer that we weren't able to do this lab together because it's kind of fun and it would have been more like a game. I'm going to read to you from our lab book. This is Lab 9, kind of the situation surrounding this game that we would have played. So it says there in the introduction, on a distant island, there is a population of animals called woollyboogers. Woollyboogers can show a range of beak shape. Some are shaped like clothespins or narrow spatulas, and rarely one finds a spoon shape. They use their beaks to find food on the island shores. Typically, their food supply consists of different beans. Each year, the woollyboogers that are most successful at acquiring food are able to reproduce. Each woolybooger needs to have at least 30 units of food to be able to live and produce one offspring. So what we would have done is each of you would have been pretending to be a woolybooger, and you would have had a particular beak. Some of you would have started out with a clothespin, and you would be trying to get beans using a clothespin. Others of you would have been little narrow spatulas, the metal ones that sometimes you use in chemistry to take different chemicals out of their container. And then others of you would have been a spoon, just a plastic spoon, and you would have tried to get out your food that way. So that's how we would have started out. And you would have had a certain amount of time to take out as many beans as you can to feed yourselves. And then when you were done, or I would call time, you would count to see how many beans you got. And as we read in that last paragraph, if you would have received 30 beans, then you survived. And if you survived, you get to keep your beak type. If you did not get 30 pieces of food, then that means you did not survive. And you would have entered into the next round as an offspring of someone who did survive. So say you were a narrow spatula, you didn't survive, but your person next to you was a clothespin and they survived, then maybe you now became a clothespin. So we would have continued to have the same number of players or woollyboogers for each round or for each generation in this particular game. It's just a matter of which beak type might you have had. So attached in the Google Classroom is an Excel document, and it should look something like this. I printed it off. If you decide to print it off, just keep in mind it's 2 pages. Don't forget this data here. And this data is from a Woolybooger Lab that was done in the past, and it goes through all the different woollyboogers, which would have been 14 people playing the game. Then if you look at the next column for generation 1, under beak type, the different letters represents the different beak types. So S is spoon. You can't see me anymore. C is clothespin, and NS is narrow spatula. So it keeps track of the different beak types, and then the next column lists how many beans they ate. And again, as long as you had 30, you could continue on to the next round. If you did not contain 30, you had to continue on in the next round as an offspring of one of the woollyboogers that did survive, and you would take on their beak type. So then you can see in generation 2, there are a different number of beak types than the first round because some people didn't make it and they had to acquire a new beak type, and then the number of beans they would have eaten, and it would have continued for 5 rounds or 5 generations. And that's all the data that you have here that you're going to need to work with. Okay, also in the Google Classroom, you should have seen a Word document that has instructions on how you're going to do this lab. So it has a sheet that starts like this. And this is important because it tells you every single beak type what their genotype would be. And if you see here, the Woolybooger beak type is a polygenic trait. And if you don't remember what that is, a polygenic trait is a trait that's controlled by more than one gene. So the letter A's are representing gene 1, the letter B's are representing gene 2. Okay, so these are their genotypes. Then on the other page, you have a data table that you need to fill out. And then it has on the third page a figure that you get to do. One more figure assignment. Shouldn't be too difficult. And I'm going to go through how you would come up with those 2 graphs here with you in a second. So what I thought I would take the time to do with you is to at least get you going on how you take this data, enter it into your data table, and then how you would go about doing your graphs. So, all right. So the second page of the Word document has the data table that you're going to need to fill out and you're going to need to turn in. So I thought we would do generations 1 and 2 together, so you have an idea of if you're on the right track in regards to what to do. So here we go. So again, this is in the Word document, second page. It says for generation 1, the frequency of NS phenotype. So how many woollyboogers had the narrow spatula phenotype? Well, to know that, you would go to the Excel data, and if you look at generation 1, can you see it? And you'd count up how many narrow spatulas there are. 1, 2, 3, 4, 5, 6. So the game started out with 6 people having narrow spatulas. But if you see, we want to calculate the frequency of that. So to calculate the frequency, and there's an equation at the bottom there to calculate frequency, you do the number of individuals having that phenotype over the total number of individuals, which was 14. And you know that's 14 because in your data, the total number of individuals there playing the game was 14. And then, you multiply that by 100 to change it as a percent. I'm sorry, it's so small. And then you would get, calculated already, about 42.9%. So 42.9% of the beginning woolybooger population had narrow spatulas. Then for the next one, the frequency of clothespins, again, you go back to the data table, you count up how many C's there are for clothespins. And there's 1, 2, 3, 4, 5, 6 again. So 6 out of the total number of woollyboogers, 14 times 100 to change it into a percent would be 42.9% again. And then the last one, the spoons. If you go to generation 1 and count up the spoons, so right here, there's not too many of those, there's only 2. So 2 over 14, total population is 14, times 100 to make it to a percent, you should get about 14.3%. Okay? All right, so now we did the frequency of the phenotypes. And again, phenotypes are physically what do they look like. But now we need to go to the number that have the particular genotypes. And so in your data table, it says, number of A, B individuals. So if you're like, okay, how am I going to figure that out? If you remember, in one of these sheets, here we go, page 1 of the Word document, it told you the genotypes of narrow spatula, clothespin, and spoon. So the narrow spatulas had 2 capital A's and 2 capital B's. So the number of individuals that have that genotype would be 6, because there are 6 narrow spatulas. Then big A, little a, big B is the genotype for the clothespins, and there were 6 clothespins. So that's 6. And then the genotype 2 little a's, 2 big B's is the genotype for the spoons, and there's only 2 of those. So a 2 goes there. Okay, so we got that part done. Then the total number, this can be kind of confusing trying to calculate the total number of alleles because we have to keep in mind that each woolly booger has 4 alleles, 1, 2, 3, 4, that's determining the type of beak that they have. So if we have 14 total individuals and they each have 4 alleles, the total number of alleles out there for the population would be 14 times 4. And 14 times 4, very good, is 56. So 56 is the total alleles we have out there in this woolly booger population of 14. All right, next. Now we want to figure out, well, how many of these 56 alleles in the population are big A's? How many alleles of the 56 are big A's? This can sometimes also be a little tricky because we have to keep in mind that, well, some of them have 2 big A's, like the narrow spatulas. Some of them just have 1 big A, and some of them don't have any. So if we had 6 narrow spatulas and they both had 2 big A's, 6 times 2 would be 12. And then we had 6 clothespins that each had 1. So 12 plus 6 would give us 18. And then these spoons had none. So 12 plus 6, we'd have 18 of the 56 alleles being big A's. Okay, then for little A's. Well, narrow spatulas don't have any little A's. So then we go here to clothespins, and they have 1 little A, and there's 6 of them there, so that's 6 of them. And then spoons, though, have 2 little A's, and we only have 2 that started out as spoons. So 2 times 2 is 4, plus the 6 here. 4 plus 6 is 10. So we're going to have 10 little A alleles. And then for big B alleles, all of them have 2 big alleles, okay? Narrow spatula, clothespin, spoon, all have 2 big alleles. So there's 14 times 2 would be 28 big B alleles in the population. If we did it right, adding up these numbers, we should get 56. And sure enough, 18 plus 10 plus 28 is 56. Okay, so at this point, your diagram keeps going down. But mini whiteboard can't keep going down. So the last 3 columns for you guys are up here. So the next thing we have to do is calculate the frequency of big A's, little A's, and big B's in the population. So again, in your Word document, page number 2, there is a equation right here for calculating allele frequency. Number of the allele over the total number times 100. So we go to calculate. So for frequency of big A allele, we had 18. And there's 56 total alleles possible. So we have 18 over 56 times by 100 to change it as a percent. I've already done the math for us. That's 32.1%. Sorry, it's so small. Frequency of little a. Well, little a here, we said there were 10 little a's in the population. So 10 over 56 times 100. In that case, we would have gotten 18%. And then lastly, the frequency of B, there's a lot of those. So we had 28 B alleles in the population out of the 56 alleles for beak shape. Multiply by 100 and you get 50%. Okay, so that's how you would go through the data for generation 1. So if you think you have that down, go for it. You can do that with the rest of them. If you want me to do generation 2 with you, continue on here. We'll do generation 2. All right, generation 2. Now we're moving to our Excel document, generation 2. As you can see, the number of spoons, narrow spatulas, and clothespins have changed because some of them from generation 1 died off because they didn't get 30 pieces of food. They came back the next generation as a different type of beak. So if you add up from generation 2's column how many narrow spatulas we have, you would see that now we only have 3 narrow spatulas. So we would say, okay, 3 narrow spatulas over, we still have 14 for the total number of woolly boogers, times by 100 would give us about 21.4%. Then for clothespins, if you look down the list for generation 2 for clothespins, we now have only 4 clothespins. So 4 out of our 14 woolly boogers for clothespins. Multiply by 100 to change it to a percent, and we get 28.6%. Then for the spoons, since they did so well, first generation wise, they came back with 7. 7 out of the 14 were spoons. So 7 over 14 times 100 would give us 50%. Okay, so we just calculated the frequency of the phenotypes. What physical beaks do our woolly booger population have? What are they showing? But now we want to do the genotypes. So keeping track of how many different alleles we have. So again, in order to be a narrow spatula, you have to have 2 big A's and 2 big B's. And we said before in generation 2, there's only 3 that came back as narrow spatulas. Big A, little a, 2 big B's were the genotype for the clothespins, and there was only 4 of those. And then 2 little A's, 2 big B's are the genotypes for spoon, and there's 7 of those guys. Let me put a 7 there. Then total number of alleles, since we still have 14 woolly boogers in our population, each woolly booger needs 4 alleles for their beak type. We do 14 times 4, and we get 56. So that number will always stay the same across all your generations. Then for total number of alleles, this is where, again, it gets a little bit different in that, well, these 3 that had a narrow spatula, they each had 2 big A's. So 3 times 2 big A's were at 6. Then these guys, spoons, had 1, and there were 4 spoons. And then those are clothespins. Then the spoons had none. So 3 times these 2 is 6, 4 times 1 there is 4, 6 plus 4 is 10. So there are 10 big A alleles in the second generation. So that dropped by 8. That went down. Now for little A's, there's no little A's for the narrow spatula. For the clothespins, there are 4 little A's. They have 1 of those. And then for the spoons, there's 2. So 2 times the 7 that have a spoon, that'd be 14, plus these 4, that's 18. So that one went up a lot by 8. And then for B's, well, they all have to have B's, so that number is going to stay the same. That number is going to stay at 28, because each of them had to have 2 big B's. Each phenotype needs 2 big B's. Okay, so then we need to calculate the frequency of each of those alleles. So again, for frequency of big A allele, we have 10 now. 10 out of the 56. So 56 total alleles times 100 is 18%. Then for little a, we had 18 this time. So 18 out of 56 times 100 gives us about 32. I'm going to drop the decimal point now. And then the big B is the same. We still have half of the alleles being big B. So that is 50%. Okay? So then you need to carry on then with generations 3, 4, and 5. Once you get done with calculating generations 3, 4, and 5, then you need to come up with 2 types of graphs. So I'm going to pause it for a second, erase the board here. Maybe I'll do a close-up quick. Erase the board here, and then I'll show you how your graphs are going to need to look. So let's see if I can do this. Not very good. Okay, is that helping at all? There. Okay, get down the numbers you need, pause it if you need to, and now I'm going to pause it so I can erase the board and show you the graphs. Teaching online is just so much fun. All right, I'm back. Little do you know, a lot has happened in the Bourne household since I hit pause before. My youngest daughter of 4 was running and not watching where she was going and ran right into a wall. Now has a big goose egg on the top of her forehead. So she's downstairs now with an ice pack on her head eating ice cream because ice cream makes everything better. So anyway, now that that's done, I can finish with you guys. All right, so in the Word document that is in the Google Classroom, on the last page, you get to do kind of like another little figure assignment, but hopefully it'll be a little bit easier because you're just making a couple graphs. So what I did over here was give you an idea of what those graphs should look like. Again, this is just based on generations 1 and 2 that we did with the data table together prior to this. So the first graph needs to be the phenotypic frequency. So how often are we getting narrow spatula beaks, clothespin beaks, spoon beaks? And I think the trickiest thing about setting up these graphs is just having to realize that you're going to have 3 data points or 3 bars per generation. Because if you look under here, green is representing narrow spatula, red is clothespin, and blue is spoon. So for each generation, here's generation 1, you're going to need to plot the percent of phenotypes. So if you recall, we started out in generation 1, we look at our data, with 42.9% of the population having narrow spatulas, 42.9% had clothespins, and then only 14% had a spoon. Okay. Then in generation 2, that changed. If you looked at your data table, our frequency was now we only had 21% of the population with narrow spatulas, 28% was clothespins, and then 50% is now spoons. That one went up a lot. All right, so then you would keep going, generation 3, 4, and 5. So again, the x-axis of generation, and then the y-axis is the percent of the phenotypes. Okay, and then the second graph you need to do is the allele frequency, which would be how many of those alleles do we have? Big A, little a, big B. So again, from your data table, for the frequency of the A allele for generation number 1, we had 32%. So now I have this little color-coded labeling here to tell everybody what everything is. Make sure you have that in your graph. And then for little a, we had 18%, and then for big B, we had 50%. And then it flip-flopped in generation 2, and now we had about 18% for big A, and then we had 32% for little a, still 50% for B. Okay? And then you're going to continue it for generations 3, 4, and 5. Make sure you use this rubric so you can get all the points that you need for the graph. Now, one thing that I'm going to say I'm going to be okay with is it does say in the rubric you should create it using Excel or Google Sheets. If you know how to do that, or it's not going to take you too long to figure out how to do that, go for it, okay? Because they will just look nice and professional and easy to read. If you're like Mrs. Bourne, that would probably take me like 40 minutes just to figure it out, then you can create a handmade graph. Better than this one, please. Use graph paper or something so the lines are neat and everything. But if you need to do one by hand, go ahead and do that. I'm okay with that. I won't dock you any points for that. Just make sure it is very neat. And again, read the rest of the rubric so you can see what else you need, like titles and figure 5 and all of those little things, so I can award you all those points. So this is due Wednesday by midnight, so please make sure you have that done. When we take our lab exam on Friday, some of this information will be on the lab exam, so make sure you do understand how to do all the calculations and how to read the graphs. So hopefully that was helpful. I know it was kind of long, but hopefully you got what you need to be able to do the lab. As always, if you're stuck, go ahead, contact me during office hours or via email. Hope you guys are doing well. One more week of college classes and then they're done. One less thing that we have to worry about, which is awesome. See you guys later.